Sine, cosine graphs right now, and then we'll probably look at tangent. So, notice how they repeat. You know, it's like boom, 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 boom. If we consider it starting here, it repeats here, which means it would repeat here, etc. So, from starting point to end point, that is, if I were to draw that, that is called the period. And then the only other thing we have is called an amplitude, and that is just the height here. Amplitude. Okay? So period is the length of a cycle. And you can start at any point. It doesn't have to start where I started it. Like if you wanted to start it here, yeah, go down, up, go here, down, up. And it's going to be the same length no matter where you do it. Amplitude is half the distance between the minimum and maximum values. So, works same on cosine functions, but here's the maximum, here's the minimum. We find whatever distance that is and divide it by 2 and you get the amplitude. Alright? Cool thing is we can find it from our equations if we were given equations. So amplitude is the absolute value of A, and the period is 2 pi over the absolute value of B. So if I'm looking here, my A value is 1, my B value is 4. So my amplitude is 1, and the period is 2 pi over B. So pi over 2. Alright, cosine, same thing. Amplitude, it's going to be 7 over 2. My B value is 1, so that's just going to be 2 pi. Period is 2 pi over B, which is just 2 pi. My A value is 5 because it's the absolute value of A. So A is the amplitude. The period is 2 pi over B. So in this case, 1/3. 2 divided by 1/3 is 2 times 3. So really that's 6 pi. Amplitude is absolute value of 2, so 2. And period is 2 pi over B. So 2 divided by 4/3 is really 2 times 3 over 4. That reduces to 1/2. So really 3 pi over 2. Alright, so let's try and graph one. Well, actually we'll graph all of them, but alright, so the amplitude is 2, and the period is 2 pi. So let's graph it. So sine, unless there's any transformations, which I don't think any of these have it, is always going to start at the origin. And so if I think of it as if it's going to start at the origin, and my period is 2 pi, it's going to end here. My amplitude is 4, which means my distance here is 4. But if I think of it as here's the x-axis, the highest is going to go as 2, lowest is going to go as negative 2. And the halfway point is pi. And I'm just doing my best. Amplitude is 5. Period is 2 pi over B. So really that's 4 pi. So So because I'm only given 2 pi, the 2 pi is like my halfway point. So cosine, let me go back and look at cosine, because I know sine better than I know cosine. All right. So notice cosine starts here at 1. It's down, up, and it's up at 2 pi, whereas sine is down at 2 pi. So let me go back. So I'm starting at 5. My halfway point is pi. But I'm really my ending point, so here. So I'm really looking something like this. And honestly, I only drew half of that graph over here, but you get the idea. But yeah, there we go. Ta-da. Alright, amplitude is 3 over 2. Period is 2 pi over 4, so pi over 2. This is cosine. So we're starting 1.5 at 3 over 2. And then I restart again at pi over 2. Pi over 2. Oh. My bad. This negative out here, if cosine normally looks like this, that negative means there's a reflection. So it actually is going to go like my sound effects. Okay, so instead of up here, it's going to start down here. So negative 1.5. And then at pi over 2, pi over 2 is here. That's when it starts again. So honestly, I can just keep drawing little dots here. And then the highest it's going to go is here. So it's going to look something like this. Ta-da. Alright, amplitude is 1. Period is 2 pi over 8 over 3. So 2 divided by 8/3 is really 2 times 3 over 8, which is 6 over 8, which reduces to what? 3 over 4. So 3 pi over 4. Alright, the negative means we switched, so sine, instead of going like this, it's going to go like this. So we still start the origin, but instead of going up, we're going to go down. So 3 pi over 4, where's that? Oh, it's already nice and fourths for us, so 3 pi over 4 is here. And then we need halfway in between that, and the amplitude is 1. So 1, 2, 3. Halfway in between that. It's going to look something like that. That was pretty good. Alright, amplitude is 5 over 2. Period is 2 pi over 2/3. 2 divided by 2/3 is really 2 times 3 over 2. So that cancels. So it's really just 3 pi. So we start at 5 over 2, but it's reflected, so we're really down here. So it's 2.5, 2.5. It's going to repeat at 3 pi, which is off screen, or off graph. So it's somewhere here. So the halfway point is somewhere here at 2.5. So something like this-ish. If that's good enough. Amplitude is 4, 2 pi over 2, so just pi. So start here, repeats at pi. So halfway between, right here, halfway between. That was awful. Something like that. And I'm only drawing like part of it. The other part would be like that somewhere. Tangent. You gotta remember, tangent is sine over cosine. So we got some weird stuff going on with tangent. Alright. So it still kind of has a repeating pattern. So the period is like right here, you know, where it repeats. Okay? And it's determined by pi over absolute value of b. Now we have these things called asymptotes here, which we know what those are. The asymptotes are odd and in multiples of pi over 2 absolute value of b. So let's just see what happens. Alright, so period is pi over b. Well, b is 1, so pi. So it means it's going to repeat and pi. So let's see, normally, when there's no like transformation or anything, so normally it starts at the origin and it repeats at pi. So I'm trying to figure out how it does the asymptote. Oh my gosh, at multiples of pi over 2b, which was 1. So multiples of pi over 2. So pi over 2 is here. So that has an asymptote there. So okay, asymptote here. And same on the other side. But it's going to look something like this. Which means it's going to look something like that. Something like that. Alright. Let's see. Period is pi over b. So pi over 1/2, which really is 2 pi. The negative tells me I'm reflected, so it looks something like this versus like that. So it repeats every 2 pi. So I'm starting here, and it repeats every 2 pi. And the asymptotes are pi over 2 times b. b is 1/2, so it repeats every pi. So it looks something like that. Repeat, so it's something like that. That's terrible. Alright, last 2. Alright, so period is pi over 2. It's going to repeat every pi over 2. Pi over 2. Pi over 2. Right. And the asymptotes are at pi over 2b, which is 2. So pi over 4. So it's going to look something like that. Something like that. God, I'm terrible at drawing. Alright. Pi over b. So it's really 3 pi over 2. And then pi over 2 times 2/3, which is really 4/3. So 3 over 4. 3 pi over 4. So we start here. It repeats every 3 pi over 2. So pi over 1 pi over 2 pi over 2. So where is 3 pi over 2? Am I dumb? I might be. period is 3 pi over 2. So I start here. That's 1 pi over 2. 2 pi over 2, 2 pi over 2, 3 pi over 2. There we go. Jeez. And then the period is 3 pi over 4. So 1, 2, 3, 4. 3 pi over 4. That doesn't seem right. So it looks something like this. It's going to repeat. So there we go, something like that. And there we have it. There's graphing trig functions.